Okay, great. Zidao, you can start.
Okay. Since I guess we have one um, audience requires English presentation, I'll try my best. But um, so some of the things I may not be able to explain it clearly in English. So in those cases, I'll switch to Chinese. But please be assured, all the presentation slides are made in English, and you can always refer to the slides to understand the major points and the highlights of the topics that I'm talking about. And the other thing is actually when I rehearsed for this presentation, I was primarily speaking Chinese to my family member because they are not in the IT industry or data science professional area. So it's easier to make them understand. But just for wider audience, let's say in the future, we have more um, people joining our group. I think English recording is going to benefit more people. Okay, but please pardon me if I cannot explain something that is very clear in English, and I will try to repeat the same in Chinese. And before going into the topics, there's one statement that I want to make, which is I'm here. Although I work for AWS, but I'm here to speak on behalf of myself. It's not on behalf of my company. It's due to the legal reasons and everything else. So all the materials you should be able to find them on the internet, and none of the materials are our internal stuff. Um, and no, I just want to make it clear. This is just a personal opinion, and it does not associate or represent any of the items within AWS itself. Okay. Yeah. So we can get started from here. So thanks Ken, and thanks for the group to give me the opportunity to do a presentation regarding a few of the data or analytics services that is provided by AWS. A little bit background about myself. I have been with AWS for a little more than 4 years, and I joined as a support engineer with our RDS relational database team, and I spent over 3 years over there. And later last year, 2019, I just felt that the analytics service, including our big data services, are seems to be more interesting compared to the RDS service. So I actually switched my team to the current analytics team, where I got the opportunities to work on a few of the star services that were provided by AWS, including but not limited to Redshift data warehouse engine, Elasticsearch, Kinesis, which is AWS managed version of Kafka. And recently, we also launched the MSK managed streaming Kafka service, as well as a few other services like Neptune DB, as Ken had already mentioned, and QuickSight, which is a data visualization tool that we provide to give the user a easy start to visualize their data source. Yeah, so basically, my topics are going to be around RDS in general. But later, I'll try to split the presentation half and half. The first half, I'll be talking about the RDS platform in general, and especially the Aurora database service, which is kind of a mystery to a lot of traditional DBAs, as well as the data scientists, because they may be very familiar with Oracle DB, MySQL DB, Postgres DB, but they heard they heard that Amazon has this built-in house database called Aurora DB, and it has two major versions. One is fully compatible with MySQL DB, and the other is fully compatible with Postgres DB. And the second half, I'll be spending time to talk about the services that I worked on in the past 6 months or so, which is the services within the analytics profile. As I have mentioned, we have plenty of services under our analytics service profile. So I'll just be talking about our data warehouse engine, Redshift, as well as our AWS managed version of Elasticsearch engine. And I know, a lot of people, may get bored if I just keep talking for the rest of 1 hour. So I decided to talk about Elasticsearch through a live demo from my personal account, where I have launched the Elasticsearch domain, and I will show you how the domain is launched, what kind of parameters you'll be using to configure the domain, and of course how you are going to interact with the domain, with your data, and play around with Kibana dashboard and everything. I guess we'll have more than 10 minutes left. If everything goes smoothly, then we can use that as our Q&A session. But I fully encourage everyone to speak up if you do have a question on any of the topics that I'm going to talk about, and I'll try to pause between some of the slides and give all the audience an opportunity to ask questions. If you cannot really speak up due to your home environment or anything like that, feel free to post a message in the chat window so everyone can see it. And I'll try to check the chat window periodically as well and see if there's any questions that I can help you answer during the presentation. Yeah, so that's a whole general blueprint of our presentation or speaking today. If you don't have any questions at this point, we'll just get started. The other thing, like I have put on my points on my slides, is that those topics that I'm not going to talk about today, because I know as data scientists or data engineers in our group, you may have more interaction with specific AWS services like EMR, Athena, or you have your own serverless infrastructure using Lambda functions, DynamoDB, and you may also be very curious about, so we're waiting on some product feature release or some of the product bug fixes, and those are the things I'm not going to cover in today's topic. I just want to make it clear. But you can still leave your question related to those services, especially those services integration into the other services that I'm going to talk about today. And I may not be able to answer them, but hopefully we will have people in the group who can volunteer to answer the question during the interview, during the presentation. Yeah, so let's just get started with RDS service in general. So those are the bunch of RDS services that we provide from the RDS platform in general. As you can see, we basically support all the major vendors of the database service on the market right now: MySQL, Oracle, SQL Server, Postgres, and of course our built-in house Amazon Aurora database. Apart from those traditional transactional relational database service, we also have the DMS service within our profile. I don't know how many people have heard about this service, but it's becoming a very popular service since a couple of years ago. Because this service we provided it for free, and we are not charging you for any of the licensing fee or the use fee of the service itself. You're only paying for the the service resource that you provision to use the service. As you may know, that almost all AWS services are built on top of our EC2 instances, and so basically you're just paying for the EC2 instance usage when you use the AWS DMS service. And we're doing this because we want to provide people a convenient way of migrating their data from their on-premise data center to AWS or from other cloud provider like Google Cloud Platform or Microsoft Azure to AWS. And we're not stopping people to migrate out as well, which means you can also migrate your AWS resources out to other cloud service vendors or your on-premise data centers. So this is a very high level introduction of the data migration service itself. And if you want to learn more about that, just feel free to type your question in the chat window, or we can leave it to the last Q&A session. Lastly, we actually added this document DB service into our RDS profile, I think 2 years ago. Even though it's not that, I would say, relative to the traditional transactional database service that we provide, because as you may know, document DB is a MongoDB compatible database service that we provide. MongoDB is more of a NoSQL database, so that's kind of a little off from what we already offered on our platform. But this is how it goes. We launch a new service, we need to find a family for the service, and we decide to put this service under our RDS profile. So we do support the MongoDB compatible database service, document DB, within AWS as well. Yeah, so RDS service, for those people who are not so familiar with AWS in general or RDS in general, RDS just stands for Relational Database Service. It's a relational database service that we provide to the customer on the cloud, so they can just access their transactional database from their web portal or from their application, and without even having without even have to manage their hardware or any of the underlying host configuration. We basically take care of everything for you, including the database engine, the underlying Linux or Windows operating system. We take care of all those backups. We take care of all those disaster recovery, the failure detection, and you have the option to scale up or scale down your service, just like any other AWS services. I don't think I need to waste too much time on this, because I believe everyone, even you have not used the AWS or have not used RDS before, you probably have an idea of what cloud computing is about. And this is just one very typical example of how cloud computing works. And easy to scale, easy to operate, and you don't have to worry about anything that is not related to your business logic. Since we're not talking about every aspect of the RDS service in general, but there's one thing I really want to mention, because during my career, when I was working with a lot of customers, developers, or even big company enterprise customers who are using our RDS service for the first time, or even those people who had been in the industry, being a DBA or dealing with the database engines for the last 10-20 years. I found that they're sometimes confused about the concepts of multi-AZ and read replica that we provide from the AWS aspect. Read replica is quite. Is someone trying to ask a question? Okay, if not, I'll just carry on. So multi-AZ is actually also replication technology or infrastructure that we provide. Um, in short, multi-AZ is a high availability solution that we provide. We do not consider read replica as a high availability solution because, as you can see from the graph, I mentioned it specifically that the read replica is using asynchronized replication technology, which means during the high workloads period, your peak hours, whether it is the peak hours for your master database or whether it is peak hours for your read replica database, you may see there's a read replication lag between your master database and the read replica database. That lag actually does not qualify the read replica infrastructure to a high availability solution. The reason being is, because of the lag, it means there's the data inconsistency issue between your master database and your replica database, which means, let's say for some reason, the master database is under great workload pressure and it crashed. So it's a huge disaster for a lot of production environments. So most of the time, people would love to fail over to a standby instance, and in traditional environment, the standby instance is not normally configured as a read replica. But think about that. If at that time your data is your read replica has not fully caught up with the master database yet, which means some of the committed transactions may have not appeared on the read replica itself. If you choose to trigger failover at this time, then your end user may experience things like something that they have bought already had disappeared from their order history, or it can be more severe. Let's use the stock trading system as an example. I may submit a limited trade order, which will benefit me with the stock market price at now. But if we fail over to the read replica, which has not recorded this specific limit order to our system yet, then the end user may lose a great amount of money. So from this perspective, that's the reason we are not considering the read replica as a high availability solution in general. But we only consider the multi-AZ as a high availability solution within our RDS profile. Then the question may become, what if I don't want to use multi-AZ? I'm more familiar with the read replica. Because in my previous company or something like that, we always use the read replica to become our failover target, or as a disaster recovery, or as a high availability solution. Of course, you can choose to do so. Depends on your business requirement, right? If you can afford to lose, let's say, that 5 minutes of data on the read replica, but to serve a bigger purpose, you want to resume your business as soon as possible. Of course, you can use the read replica as a failover target and just a failover to it, and choose to lose the 5 minutes data that has not been replicated to the read replica instance yet. That's definitely an option for you. But the thing is, we do already have a better solution called multi-AZ here, which will take care of the replication in the backend for you. And when your primary instance fails over to the secondary or to the standby instance, we can make sure that all the committed transactions will appear on the secondary instance for you. So if we have that option, why not using it? So that's a whole point here. Then
Sejal,
yeah, yeah.
a quick question. So, given the advantage of the multi-AZ you just mentioned, so I wonder if a multi-AZ solution is a lot more expensive than read replica, or roughly similar.
Yeah, that's a very, very good question, right? So if we have such an excellent feature here, uh, why don't you use it? So the budget or the cost concern is the number one concern for most of the customers. Yes, it's going to be a lot expensive because instead of paying just for one EC2 instance and the underlying storage, if you enable multi-AZ, you're actually paying for two instances at the same time. And the bad news is, even you are paying for two instances in the ADA multi-AZ infrastructure, you are not actually using the secondary instance because it's just, staying there as a hot standby where, you only use it when a disaster or something else happens to your primary instance. Um, so for read replica, it's actually the same because when you create a read replica instance, you are also paying for the second instance that you provision. You're also paying for the additional EC2 instance and the additional EBS volumes that you provision for the read replica. But the good news is you are actually um, able to access this read replica instance itself. So if you are not just designing this read replica for failover target or for high availability solution, you can actually balance your read traffic out to this read replica. We will give you the specific endpoint of the read replica where you can put that endpoint into your application connection strings or into your MySQL Workbench or whatever clients that you are using. So you can interact with this read replica directly. And the thing is, read replica, just like by the name, it's read only. And for all your write traffic, you will still need to connect to the master database. But for the read, maybe you have a team that is only doing select heavy queries. You can direct all their traffic to the read replica. So you are basically taking advantage of the read replica that you provision. You're using what you're paying for. Unlike the multi AZ, you only use it when something happens to your primary instance. So from budget and the cost perspective, those two are pretty similar. I think we do have a small discount for multi-AZ compared to the read replica itself because we know that you are not actively using this instance. You are only putting it there as a high availability option or solution for potential hardware failure or disasters in the future. So this is one major difference between those two. Let me see if we have any questions here. For database migration from local MySQL to RDS. Yeah, so replication is definitely a big topic. If you're just trying to migrate from your local MySQL to, let's say, RDS MySQL or a different database engine, let's say you want to migrate to RDS Aurora MySQL, we actually provide the MySQL native replication way, which is by utilizing the bin log of your MySQL database server. You can basically take a MySQL dump on your on-prem database server and then restore that dump to the RDS Aurora MySQL or RDS native MySQL, and then just replay the bin log from the position where you took the dump. So that's going to be the recommended solution by using the native MySQL replication way. Of course, you may also choose to use DMS service, which is more, I would say, straightforward because the DMS service, we have the logic internally to fetch the bin logs for you, so you don't have to mess around with the operating system and MySQL administration tasks by yourself because DMS just does it all for you. Of course, you pay extra money for the resource that you provision for the DMS server, as well as you may have to handle some of the potential, I would say, potential issues that you may you may encounter in the future. Because if something breaks during the replication process, comparing to just fixing the connection between your local MySQL to RDS MySQL or RDS Aurora, you actually have one more layer in between, which is a DMS server, where you have to isolate and troubleshoot to see where the problem is. So yeah, there's some overhead for configuring DMS for this setup. So, but our recommended solution is to just use the native replication method to simplify the infrastructure and make your life easier in the future. Okay, sure. Yeah, we can move forward. Yeah, so this slide I further highlighted some of the difference between a multi-AZ and a ready replica. This is very important because by understanding it, you can save a potential greater amount of money or budget for your team and for your company if you know exactly what you are looking for and which solution is meant for what purpose. So yeah, so this is just a major point I want to talk about. So if you look at the highlighted bullet points, you will also notice that apart from load balancing, synchronized replication versus asynchronous replication, um, I also mentioned one bullet point in the multi-AZ that you would experience the performance punishment, which is number 3, the last bullet point under multi-AZ. What does that mean? So it's every technology you choose to use it. It's mostly a double sword, right? It has its advantage and it has its drawbacks. So the performance punishment is a number one drawback for enabling multi-AZ because think about it, it's a synchronized replication, which means we would have the additional logic on your host to check if the two databases are actually in sync. So you may experience some performance degradation when you enable multi-AZ infrastructure because we have the extra code and extra logic over there to actually see if the two hosts or the two databases are in sync all the time. So there's some punishment in terms of that. And the other thing, which is would actually matter more in terms of punishment, is if your secondary instance has some latency issues that are happening on it. Let's say you have a transaction that is waiting to be committed on the primary instance. Well, the secondary instance, it has a network issue or it has some hardware issues that cannot commit that transaction. So in this case, because we want to make sure that the two databases are always in sync, right? So we will choose to wait to commit that transaction on your primary instance. So you're like, that doesn't make any sense, right? I'm not even using the secondary instance. Why are you holding my transaction on my production primary instance? That's because we want to ensure the synchronized replication. But the point is that if we choose to hold that transaction forever, of course it sounds stupid, right? Because the production database is still usable, it's still healthy, and I don't see any issues with it. Why are you holding it just for a standby instance sync up purpose? So we actually have a threshold. It's only a few seconds. If we cannot hear back from the secondary instance for the transaction commit, then we'll just give up. We'll just say, what, I'll just commit the transaction and let the customer do whatever they want. And we'll put the secondary instance offline and try to fix it in the backend and then put it online again to resync with your multi-AZ instance. Well, that doesn't happen a lot, but it does happen, right? So during this period of time, while the secondary instance is offline, you have to cross your fingers and hope that the primary instance doesn't go down, because right now you're basically running on a single AZ instance, which is a single node. if during this time something happens to a primary instance, you don't have a solid failover target to failover to. So the overall downtime will be the secondary instance bring back online time plus your primary instance going back to healthy mode time. But during all my years with AWS and when talking to different customers, I have not seen something like that happen. Because we put those instances, primary and secondary instance, it's multi-AZ, right, in different availability zones, which is a term for multi-AZ, which means they are going to be geographically located at different data centers that is managed by our team. So unless the two data centers were, experiencing hardware failures, network issues at the same time, that doesn't happen. And for multi-AZ infrastructure, we have the SLA, service level agreement, to give you 99.95% uptime throughout the year if you choose to enable it. Yeah, so it's really great high availability solution that you should consider. And going to the read replica, I also mentioned that you can use the read replica for upgrade testing. And what does that mean? That basically means let's say you have a database engine upgrade project that you need to work on, right? Simple example, you are running on MySQL 5.5, which is a pretty I would not use the word outdated, but it's a pretty old version, right? The latest version is already going forward to 5.6, 5.7, and 8.0. So you're really falling behind. So some companies, they want to upgrade their database engine to a later version or to the latest version. So you can definitely use the read replica method to test this newer version, because once you configure the read replica, it's actually an individual instance that is only replicating from your primary instance. It doesn't require it to be with the same engine as your master instance. So basically, you can choose to upgrade the read replica instance to a later version and see how your read traffic does on the read replica instance. And let's say after a few days or after some benchmark testing, the read replica was handling all the read traffics perfectly. Then you may try to cut over the read traffic to your read replica as well. But at this time, you will actually need to promote your read replica to a standalone instance, because it's read only. When you have to actually promote it to a fully functional individual instance in order to take the writes. And if something happens, it doesn't work as expected. Remember, you still have that old master database on the older version that is running, and you can just make the decision to quickly fail over back to the older master database without even having to worry about the read replica, because read replica is kind of cheap. Even you promoted it to be an individual instance, and you find it's not working for you, you just feel free to delete it, and you can always create a new read replica from the original master database and continue doing your replication or using your older version database engine like before. So let me just check again if we have any further questions here. Yeah, multi-AZ and read replica, they are not conflicting concepts, so conflicting setup. And of course, you can always enable multi-AZ and choose to have your own read replica at the same time. And I think we also support read replica multi-AZ which means you can also build a multi-AZ for your read replica instance. Let's say if your original infrastructure has one master database and three read replicas, if you choose to enable multi-AZ for every instance, you end up with altogether 8 instances. So basically, you just doubled the instance count. You're paying more, of course, but you have better and higher availability for the overall infrastructure. Okay. Finally, we got to the point to introduce Aurora. Um, so Aurora is a clustered database solution that we provide. We say it's a MySQL or PostgreSDB compatible. Um, that means we actually borrowed some of the open source database engine code into our Aurora platform, but it doesn't necessarily work like MySQL or PostgreSDB. What do I mean by work like them? Because due to the infrastructure difference, this is the cluster database. Um, you may find some of the query execution or some of the parameters are not there, like MySQL or PostgreSQL. So because we actually have our own methodology to rewrite the query or to execute the query in a way that is going to utilize different CPU, which is going to utilize more threads, which is going to utilize potentially more RAM space to execute a specific query in those cases. Not necessarily Aurora is utilizing more resources compared to traditional MySQL or Postgres database engine, but you will expect to see some of the behavior difference when you choose to use Aurora, MySQL, or Postgres compatible database engines. And of course, going to the multi-AZ concept, like I mentioned, for RDS MySQL on the left, it's your choice, it's your option to configure a standby instance for your MySQL database. However, for our Amazon Aurora, we don't even give you the option to actually enable multi-AZ or something like that, because by default, even if you're only launching one node, single node Aurora cluster, we actually provision 3 data copies at the storage layer for you across 3 different AZs. Then your question becomes, am I paying for all those resources? What if I just want to use a single node for my dev or for my testing environment, because it's not a critical environment, right? I want to save money. Of course, you can choose to do that. You're still paying for the whole infrastructure, for the extra copies that across the different AZs. But the thing is, if you compare the price, we're not charging you more compared to single AZ RDS MySQL database. So basically, we provide those extra redundancy from the storage layer to you for free. So just relax and go ahead and configure a single node based on your use case, and enjoy using Aurora database. However, for production database, let's say you have been using Aurora MySQL in your dev and test environment for a while, and you really like it. You want to bring it on to your production environment. We always recommend a customer to provision more than one node for a production cluster. You can do 2, you can do 3, you can do 10. You can do whatever number you want. We do have a upper limit of 15 reader nodes, which means the maximum limit for Aurora cluster is going to be 16 nodes. But I have not seen any customer who is requesting more than 15 nodes. A lot of the cases, it's 4, 5, 6 nodes are going to be enough to serve their production workload. Because remember, by adding the extra node to your infrastructure, which is considered as a scaling horizontally, which means you are just adding more servers to serve your traffic. We always have the option, like traditional database, to scale vertically, which means you can always scale up your instance type, right? Let's say you are using a 2x large instance with 8 virtual CPU and 60 gigs of memory right now. You always have the option to upgrade the instance itself to a bigger one. Let's say 16x large. You have let's say 64 virtual CPUs and 266 gigs of RAM space that you can use. So it's always an option to you to choose to scale horizontally and scale vertically to meet your specific business requirements. Yeah, so this is about the Aurora major difference compared to the traditional multi-AZ RDS instance. Let me check the chat window again, because I do believe we have a few new questions here. Same hardware, and Aurora Postgres is slower than Postgres RDS. Yeah, we do get a lot of questions like this, and customers are happy when we try to introduce them to use Aurora Postgres, and they were trying to spin up the same instance type because they feel the same instance type is always enough for their original RDS database engine. This is really a case-by-case issue. We do have happier customer where they see that it's an excellent introduction, and I do have my performance boosted without spending extra money just by migrating to our database. So because I don't know the full context for this specific question, we do actually need to look into that. And I encourage you to create a support case with us and provide some of the performance data to our team. And we'll have to look into your parameter configurations and your benchmark testing results, as well as your overall setup for between your Aurora Postgres database and the traditional RDS Postgres database, because there are too many factors that may impact the performance difference, and we need to see the data and the fact in order to provide more insights into the issue. Yeah. Okay. One more slide for our database. Actually, not one more. I still have one extra slide after this for our is the endpoint concept. For people who have already used Aurora, I don't think I need to spend too much time on those topics. Basically, cluster endpoint is the endpoint for your master node, which is a read and write capable node, where you can connect to the cluster endpoint and route your traffic to the master node only. Reader endpoint is pretty good solutions that we provide to the customer to manage their load balancing to all of their reader nodes, which means if you have 6 nodes cluster, right, 1 master node and 5 reader nodes, you mostly use the cluster node for all the write traffic, but for read traffic, you may choose to use the reader endpoint, which is only pointing to the 5 reader nodes, and they will do round robin, which will send your request to a different node each time when the request comes in. So you don't have to configure your own load balancer or anything like that, because we just manage all of this for you in the backend. You just go ahead and use the reader endpoint to balance out your read. Instance endpoint. This is very similar to the RDS instance endpoint itself, which means in the 6 node cluster infrastructure, all your 6 nodes will have their own instance node. But even they're there, and the customer can check them out and see what the instance node looks like. We never recommend customer use the instance node itself. The reason being, let's say you're using an instance node for your master node, right? What if someday the master node has a hardware failure or has a has a connectivity issue? Because you're only using the instance endpoint itself, your request is still going to be sent to that specific instance itself. But if you're using the cluster endpoint, if we detect you cannot actually connect to the backend instance itself, we'll just trigger the failover for you, and the cluster endpoint will be mapping to a newly promoted master instance, which will provide the high availability for your traffic in general. The same theory applies to the reader endpoint and the individual reader replica instance endpoint as well. Because if you're using a reader endpoint, we have the mechanism in the backend to do health check for all the readers. If we find there's one reader or multiple readers that is not functioning properly, we'll just remove those those DNS entries from this reader endpoint, and your request will be forwarded to the only working reader instances. So that's a reason we are not recommending using instance endpoints in all of the cases, because if you do have a specific requirement to use your favorite group of instances, we have the following, the fourth endpoint, which is a custom endpoint, which means you can configure several of your readers to work as a group with a specific endpoint, and the rest of your other reader replicas to use a different endpoint. I will give you a very specific example for this custom endpoint use case. Let's say in the 6-node setup within your company, and you have multiple departments who are doing read-only to the cluster. But not every department has the same priority to use the reader endpoint, right? So you have the finance department, which is has a higher priority compared to the HR department or compared to the logistics department. Then you may want to guarantee that the finance department read request will be prioritized. So in those cases, you can create a custom endpoint for, let's say, in the 6-node setup, we have 5 reader nodes, right? To configure a custom endpoint to 3 of the 5 reader replicas. So the 3 reader replicas will only be used by your finance department, and then configure a second custom endpoint for the rest 2 reader replicas, and they are going to be shared by different departments like HR or logistics department. So in those cases, you actually allocate more resource for your first custom endpoint to be used by your finance department, instead of you're treating them evenly, and everybody is using the same endpoint and access the instance in a round robin fashion. The last part, global database. I don't want to spend too much time on this, but in short, global database is just a cross-region replicated cluster that we provide to the customer, and you can read more about that from the link below. Because all AWS services are based on region, which means when you launch an AWS service on your console or from the CLI, you have a default region or selected region from top left corner or from your CLI configuration profile, which means the resources are only going to be launched in one particular region. But global database gives you the option to launch a common resource across 2 different regions, and they will be doing replication cross region instead of just a region-wise replication. So this is something I would say we do not see too many people implement. But if you do have this requirement to do replication across the globe, let's say from US Eastern region to to Japan, Tokyo region, you can definitely configure the setup using our global database. Yeah, I think um, we have new questions here. Master to master replication. Uh, because I have been away from our RDS profile for a while, I don't know the progress on this master to master replication product. But when I was there, I think it's still in beta, and only customers who were whitelisted or who registered for the specific feature would be able to launch or see the feature itself. I don't know if it is GA yet, global, accessible yet. So I'm sorry, I cannot provide insights into this. I need to check out our public release documents to see where are we for this specific feature. I know this feature was announced, I think, back in 2017 or 2018 re-event. It's been a while, but I just lost the track of the feature after I left the RDS team. But feel free to check out our official documentation and try to register for this feature, and we'll put your account whitelisted, and then you can start playing around with this feature. Um, I also so I guess there's one. I think this is for the number three servers is meant for the for the redundancy that I was demoing in the previous slides. Just want to make it clear, it's not actually three servers, but it's three redundant storage copies, which means we do not have those instances ready for you, and you still have to provision your own data nodes in order to utilize the underlying redundant storage. Yeah, so it's not meant for servers, but just for storage layer redundancy. And just a little more insights into that. Those three redundancy storage layers, they are replicating to each other, and this is something I want to introduce in the yeah. So here I just put some of the benchmark testing results here, because I have been talking about Aurora, and the people are talking about Aurora all the time. They want to know what's the big deal about it, and how can we benefit if we choose to migrate to Aurora. So we have our official Sysbench testing results available from the public-facing PDF file, and you may also use the third-party Percona website to check out their benchmark testing results. Just want to make it I would say a justified, a fair evaluation of the product, because if we just say our product is good and you just need to refer to our benchmark testing results, it's not persuasive enough, right? So, but if the testing is done by one of our competitors, Percona, they also do their own commercial engine version of MySQL. So they also did a benchmark testing with their product to compare to our product. So just feel free to read it through as well. And I'll put the conclusion here, because I read their benchmark testing thoroughly from the link that I provided. The conclusion is that if your workload has this great high demanding volume, I/O throughput, or whatever, um, um, I would say dynamic requirements, then provision a bigger Aurora cluster is going to benefit you more than provision the same size Percona database server or RDS MySQL server. However, if you are just doing regular transactions, and you don't have those crazy high high peak load during some of the seasonal sales or something like that, then choosing a smaller instance type from Percona or RDS MySQL or your own on-premise MySQL is going to benefit you more compared to choosing a smaller Aurora database. So just in short, provision a bigger Aurora cluster to serve high demanding workload traffic is a recommended solution compared to others. Yeah. So this is some of the other documents that I want to share. We actually this is actually from our Aurora team itself. This is a paper, right? You're looking at it at right. When the product was first launched, we have the theoretical, stuff in the backend to support the infrastructure, and we published a paper for it. And if you're interested, feel free to read about it. There are a lot of things I still don't fully understand. But if you're really interested in how cluster database works in the backend, what kind of algorithm, what we call as a quorum, yeah, right, quorum, in terms of cluster database, just feel free to go over this public facing paper for the infrastructure support in the backend, as well as Wikipedia for what quorum stands for in distributed computing system. And yeah, and the third one is a further third party blog post regarding how Aurora handles the traffic in the backend in more details. Okay, let me see how much time we have spent on this. Yeah, I think we're a little bit over time. I spent too much time talking about RDS and Aurora in general. But from here, I will try to speed up a little bit, talk about Redshift and Elasticsearch. So Redshift, I just highlighted some of the points here. Columnar storage. If you work on Hadoop, if you work with Parquet data format, you should know the columnar storage very well. So it's a way to handle analytical workload compared to. Sorry, someone has a question. Oh, I'll just carry on. So the main benefits of columnar storage is that the compression ratio can be really amazing. So Redshift used our own encoding or supported encoding like AZ64, LZO, ZSTD. But I'll be using Parquet encoding as an example. So I think the ratio for Parquet encoding is over 96%, which means if you have 100 gigs of CSV files and you choose to compress it using Parquet format, the Parquet file eventually is going to be less than 4 gigs. So that's how amazing it is to use specific columnar storage and related compression technology to save your data. And that being said, you actually save a lot of the storage by compressing the data or encoding the data in a certain way. But nowadays, when all the hardware just becomes cheaper and cheaper, and people may not worry about the compression or encoding that much, then they will course. I don't care if it is 4 gigs or 100 gigs for me, because storage is cheap. I can just purchase a bunch of new volumes and attach to my device, and they can use whatever storage they want. The point is is that storage saving is just one aspect. If you think about the hardware limit from the physical device layer, it actually benefit you more from the hardware limit perspective, with the primarily the I/O save. Because when you were trying to parse 100 gig from the hardware device, the hardware may has its 1 gig network throughput or something like that. It's going to take a while to actually transmit the 100 gigs of data, right? But think about if you compress it to only 4 gigs, then the I/O save as well as the hardware communication to each other will be more efficient and eventually benefit you more from the performance perspective compared to the storage save as we talked about earlier. So that's a main point of using the different encoding and compression and the columnar storage itself. The second thing for Redshift, I don't know if the same concept also applies to other data warehouse engine or EMR cluster or some other big data or analytical service or not. But we have this thing called the distribution key and sorter key. Just by the name, you can assume that those were just for your data distribution across the nodes and your data ranking when it resides on each node. I'll give you an example. Let's say you do not define a sort key for your order table, right? But for analytical service, we mostly run, let's say, transactions like I want to see the last 10 years transactional data based on season. So for this particular query, it's actually going to scan the last 10 years order data. It's going to be a huge amount of data. And if you don't have a sort key that is built on top of a timestamp or date column, then the data is going to be sorted in a way that is by default by default or using some hash value to sort. Then when you run such kind of queries, I just want an aggregation by day or by season or by quarter. It's going to be very inefficient because the data is basically sorted in a way that is not ranked by the date or timestamp itself. That has the disk has to scan here and there to get whatever you want, and then group them together to give you the report that you want. So that doesn't mean that you have to design the sort key as your timestamp or the date column of your data warehouse engine. You always have the option to define a different key. Maybe it's a user ID, maybe it's a product ID, maybe it's a vendor geolocation information. Just you have to think about what is most of your business logic or your use case is going to look like in the future, and then you choose to define whatever key that you want to define for your particular table. And even you make a mistake at the beginning, say that, hey, I imagine in the future we'll be doing a lot of aggregation based on the date or based on the timestamp. So I would just be choosing the date as my sort key for my Redshift cluster or other data warehouse engine. But when the business grows and when everything changes, your business requirement may change, and I may not be curious about the date report anymore. I'm more curious about the geolocation sales data, geolocation order information to inform our marketing team to spend more money on the advertisements in the specific geolocation. So then you were like, but at first we were using those date aggregation for our data warehouse engine mostly. How can we do that? You always have the option to alter your table to choose a different sort key at a later phase, or but that's actually considered as a huge maintenance task, because by altering the table, you are basically reallocating all the all the block storage to a different physical address on hardware, and which will cause a considerably long time exclusive lock on your table itself. Of course, we do have some other solutions to minimize the locking period for your major fax data, and some tools for you to choose from to do this kind of operational tasks. And that's another topic I can try to talk about that in a different lecture, or in a different setup in the future. And then moving on. Redshift, we also started supporting external tables, which means you don't have to have the data located on the Redshift storage layer itself. We do support you use S3, the simple storage service, as a data lake service for our all the other AWS related technologies, which means you can keep your raw data, or you can keep your raw packet file on S3 bucket. And the only thing you need to do for Redshift to communicate and interact with that data is you define external table schema for those data that is residing on the S3 bucket. Because think about that. Redshift doesn't know what the data looks like on S3, and S3 doesn't know what kind of schema Redshift would use to actually query the data. So you actually have to utilize our Spectrum or the Hive MetaStore. We currently only support those two external catalog or schema storage media, where you can keep the table. I would say the table DDL over there to be used as a connector between your Redshift cluster and the raw data on S3. And yeah, we do have other services that can integrate with S3. So the whole purpose is that we want to build a data lake solution where end users can simply put their raw data or whatever format they want into their specified S3 bucket and other service without having to load the data into their storage engine themselves. They can just use the data directly without having to worry about the whole ETL process between the S3 and their own preferred database solutions. Yeah. So last two part. Tony Skips is our principal data warehouse solution architect, and he actually has those deep dive videos on YouTube where you can search. And a bonus point here is for any AWS topics that you are interested, you can just do deep dive in your keyword searching, and you will see a bunch of re-event videos as well as public facing training videos to talk about the specific service in detail. I think Tony gives he gives our Redshift deep dive video on our re-event in the past 3 years at least, and I actually watched them again and again to because every video I learn different things from them, and they do have a lot of redundancy because some of the topics that Tony Gibbs has to reiterate every year. But I don't feel it's a waste of time. Every time I watch it, it just kind of help me to think more about the specific topics that he was talking about and understand the service itself in more depth. So just a trick here that you can search for those videos. You can also do deep dive DynamoDB. You can do deep dive Lambda function, deep dive SQS service, deep dive Kafka service, and we have all kinds of videos on YouTube for the public to view. Okay, finally, let me see how much time we have left. It's 3:21 now. I'll try to make this quick because I think initially we have this presentation scheduled for 1.5 hours. I guess a lot of people won't be here that long, so I'll try to make it quick. So what is Elasticsearch? If every time when I try to introduce people, introduce Elasticsearch to people, I tend to use Google as an example. So Elasticsearch is just, you can imagine it's an engine that is supporting Google in the backend. Of course, Google they may have more advanced technology to support this, but Elasticsearch is more like a Google. You can do global search for whatever value field or data that you're interested with. Because when you let's say when you write a new blog on Medium, right, and you put some hashtags over there, and your blog has several paragraphs and some pictures over there, and but Google is not going to only index your blog post tags, because you may only have 2 tags there, and which doesn't mean only people who are hitting those 2 tags, the keyword, are going to find your article, because Google is basically going to index everything you put into your blog post is going to be indexed in Google. And as long as there's a higher percentage of match of your blog post contents, it's going to be a hated result in Google's return. And Elasticsearch is something that does similar. That Elasticsearch is a tool that does something similar in the backend to support this purpose. And a few important concepts here. I know I don't know how many people have used the Elasticsearch service before, but a lot of people try, including myself. When I try to learn new things, I try to try to see what is infrastructure, what is the terms can be I would say mapped to something that I know already. So cluster, node, no fancy terms. It's just like a cluster database or the node of the database. Those were just a hardware concept. Index here or indices. Indices is the plural form of index, which takes me a while to figure out. I just want to point it out here because I thought index, the plural form is indexes, but it's not indexes, it's indices. So it just means many index. That's what it means. And index, you can map it to the knowledge of database that you know. Back to the relational database or data warehouse engine concept. It's just a database. Let's say I have a customer database where I store all the customers' order information, customer information, as well as some other address information, things like that. So it just means database. And shard. This database also has a terminology shard, and it's doing something similar. Let's say on someday your database just becomes so big, and what you do? You partition it, right? You break it into small pieces, and so that when you try to access it, it will try to access the partitions at the same time, or it try to access more I would say related partition to fetch the data that you want. So shard here is similar. When the index becomes so big, you can choose to break it to different shards. But Elasticsearch, of course, we know, because we're indexing everything, we are not waiting until the point it becomes so big. We choose to do the shard. We do the shard when we first create the index, because you have to understand your use case or understand your data volume very well before you actually touch on Elasticsearch. Because the requirement of shards, let's say if you don't design it properly at the very beginning, let's say I want 5 shards, or I want 10 shards, or I want 200 shards. If you don't have a general idea of what your data is going to look like in the future, or what your data volume is going to look like, you will end up with a bad design. You will put either too many shards over there, which is going to cause a lot of heap, and because it's based on Java, right? So the garbage collection and everything is going to work crazily to manage the memory leak, because you have so less data but so many shards. Most of the resources are going to be spent on managing and allocating the workload for you in the backend, instead of doing the actual computing for you. If you have too less shards, the shard becomes so big, and if there's a disaster happens, the shard recovery is going to take forever. Or if the shard becomes too big, it's going to explode your underlying storage or anything like that, or it's going to cause the search pretty slow because you can do one search split into 5 shards at the same time, but you only design it to have one shard. It's going to be just one search in that shard and scanning 10 terabytes of course not 10 terabytes. I think there's a harder limit for that as well, but it's a big number of data within that one shard, and it's taking forever to find what you want. So shard as well as a replica. Replica is not fancy at all. It's just a copy of the existing shard or existing portion of your index, and it serves for high availability purpose as well as to balance out some of the requests to the reader replica itself. And you can design one reader replica, two reader replica, 5 reader replica based on your needs as well. Because like I said, it also serves as a major load balancing data points that you can use. Document fields, those were documents because I can't say documents is exactly table that is mapped back to a traditional database. It's documents. I would say it's more like a record instead of a table, because actually Elasticsearch does not have something that can be mapped easily to a table concept. So it's just a database itself, and then it comes to the documents itself. So it's I'll show you in the later demo what the document looks like. Fields, of course, it's whatever you have in your document. The one document can be a specific Apache weblog, and it has a timestamp, and it has a source IP address, it has a client operating system version, it has a client browser version, it has a destination IP address, it has it may have a port number or the response codes, HTTP GET or HTTP post request, whatever that you can put into a log, and those individual atom or nested value items are called fields inside a document in Elasticsearch terminology. So yeah, here's just a graph or a diagram that I copied from the internet, where you can use as a reference to understand what is a shard and what is a replica in within an index. And you can see that it's trying so hard to put the same shard, different replica across different nodes for redundancy and parallel computing purpose. And there are a lot of documentation outside to give you a more in-depth explanation of what these are and how this work in the backend. Oh, the other thing is you don't have to worry about how the data is going to be allocated in the backend. This is all Elasticsearch engine's job. It will does the allocation for you. You only specify the number of the shards that you want. You only specify the node of your cluster of your domain that you want to provision, and Elasticsearch will do all those logic for you in the backend. And of course, this is Elasticsearch in general. This is not Amazon Elasticsearch specific, because Elasticsearch is a open source and is a community search engine that everybody can use. Amazon just manage the infrastructure and manage all the configuration for you, which make it easy to start. Okay, I'll do a demo if we still have time. I don't know if we still have time. It's 3:30 now.
Yes, you can go. Yeah, you can go ahead. Yeah.
Oh, okay.
I think before that there is a question regarding Redshift Spectrum. And
okay.
you want to address that?
Not really. I won't say. Well, I will say overlapping. Yeah. There, a lot of our services has certain sort of overlapping with each other, and they seem to serve the same purpose in some areas. But if you think about that. I don't know Asana very well, but I used Asana once. I think it supports only, it has a lot of limitations, like query execution time and the query complexity itself on the dashboard. But as a data warehouse engine like Redshift itself, it doesn't have those limitations. You can write your 100, 200 lines queries to get you want, but I doubt that's going to be achievable from Asana, because Asana is more of a, I would say, a web portal where you have a limited I would say features or spaces there to put in your work logic. Yeah, so I don't know if that answers the question, but we can talk more about it in the in the Q&A session. Okay, let me see. Yeah, so this is I made a screenshot, but I'll do a demo to tell you how this is going. This is already created 5.1 engine version, Elasticsearch engine, and you can see it has two endpoints. One is the instance endpoint itself. The other is the Kibana endpoint. I'll tell you what the Kibana is in a short bit, and you can choose instance type just like any EC2, RDS, or whatever other AWS services you have. Instance count, how many nodes you want to have. So those are, like I said, those are going to be predetermined, preferably. But if you can't determine, we always have the flexibility to upgrade those instance type as well as the instance count in the future. But for the shard and the replica configuration, you will actually have to calculate it thoroughly before you determine how many shards or replicas that you want based on your existing data volume and workload. Because you can also change it in the future, but like I said, it's more of a maintenance operation. It's going to cause a considerably long, I would say, outage. It's not outage because if you use AWS Elasticsearch, we actually do this in a way that won't bring down your cluster or your Elasticsearch domain. You will only experience performance degradation. But just plan for it carefully before actually put it into your production system. Yeah, so I will just quit this PowerPoint for now. I'll just log into my AWS console, and I will give you a quick demo of how the instance is being created and everything. Yeah, I didn't use my work domain. I just used my family members' AWS account, because this is a personal opinion. It has nothing to do with my company. So if you have AWS, you would you would see the same here. Pretty straightforward. Production development is we just default some of the options for you, and I'll just use development in this case, and choose your engine virtual engine. You'll see the engine release from both Elasticsearch community as well as our public documentation to see the new features available in each engine version. And next, you give it a name. Let's call it ES demo, and choose your instance type. Let's keep it default. Number of nodes, I'll keep one node here, but it's not the best practice, which I'll tell you why later. And the underlying storage EBS, just like any EC2 instance or RDS instance, you choose the different storage types and provision the space that you want. Dedicated master node. So since this is a cluster based domain, you actually need one kind of leader node or master node over there to allocate the resource and distribute the request to the different data nodes. So dedicated master node, which means your provision a new just a node over there working as a master to do this kind of work for you. But feel free to uncheck this if you want to save money and just want to play around with it, because in this case, the master node job responsibility will be assigned to the data node because it's just what I think is just an agent that is located on the host to manage the workload for you. So it just for testing purpose, you can just keep it on the data node to manage it for you. And automatic snapshot, just like RDS, it does a snapshot backup everything for you. Advanced options. I don't think there's we don't need to configure anything there, so I just collapse it and moving on. The network configuration, VPC access recommended. Why we recommend VPC only for Elasticsearch? Because it's more of the data layer in your infrastructure, right? So you want to keep it in your VPC, and only resources from the VPC can resolve endpoint, can access the instance. But just for testing purpose, if you don't want to configure a reverse proxy server to access the Elasticsearch domain, you can do public, and you can limit the access list to your specific IP or IP ranges only, and so you can visit it directly from your home laptop. This part I'll also skip because this is going to be another topic, the fine-grained access control. This is we're going to utilize a third party, not a third party, but a community plugin called Open Distro, which is another 2 hours lecture where you can configure those really advanced fine-grained access to limit a specific user or group or role to access only specific index or even specific document or specific range of document or specific fields, or mask some of the fields for the user. So this is going to be a lot of information to talk about. So I just skip this as well to uncheck this option. And if you enable this, the AWS console UI or the Kibana UI is going to look totally different from not totally different. It's going to look more complicated compared to the regular ES Elasticsearch UI. Cognitive authentication. I will skip this as well because this is another security service that we provide. And it's more, yeah.
If you can skip all the details, I think you better finish in 5-6 minutes. Just,
okay, sure.
Skip the details. Sorry.
Okay, sure, yeah. So access policy, this is the one I talk about, and we can just skip this. Let me see if I can. Let me see if it will let me. No, it doesn't let me to go to next. But the next screen is going to be a confirmation screen. It doesn't actually tell you too much. It doesn't have too many other configurations for you to config. So I'll just skip this. So once the cluster is configured on your dashboard, you will see a domain like this, like with the endpoint I already talked about, and to interact with your Elasticsearch domain, you can use the endpoint and use your custom API call from your SOAP or from your Postman third-party tool to make the post or put or get API call to the service, or programmatically using the API standard Elasticsearch API call to interact with it. But it's not ideal, right? A lot of users were like, do you have a client like just a MySQL Workbench or something? I can personally log into the system. That's when Kibana comes into the place. Kibana is also a plugin that is supported by Elasticsearch, and it's kind of a straightforward way to access Elasticsearch. So I'll show you what a Kibana dashboard looks like. So this is when you hit the Kibana endpoint, it will take you to this page. It's actually a web UI for you to access your data. Let me see. So I'll be quick here. This is a dashboard. I have some data into my system already, and as you can see, those are web logs. It actually logs the information for people who access the log in a certain way. Let's do last 30 days data. Yeah. So you can see we automatically generate this web log heat matrix for you. it's a count based on 12 hours period of time. And this is what the raw log data looks like that is being imported into the Elasticsearch DOM. If you expanded it, you will see the JSON format of the log, what it looks like, and you will see we structured it in a way that you can easily understand what fields, what value you have in this particular specific document. And then what about what if I want to search it? So let's say it's a weblog, right? I want to search for 404 errors. I just type in 404. And this is a pretty dummy demo. And here you see it actually gives you some unrelated results because this is 40480. It's not actually a response code. I'm curious about response code. So just to be more specific, you may do this. Yeah, here it's more accurate, and you can see how fast it is. And it's basically indexed every potential values in your document. And this time you add this response here that gives you a 404 code as expected. And there are more fancy queries. It has a long. I have some history here where I can try to see agent. I want to see like how many people are using Google Chrome to access my website. So it gives you the Chrome user data. And you can further visualize those data based on your business requirements. And moving forward, the visualize we actually give you some of the built-in ready metrics, and I click on the heat map metrics, and we'll show you the heat map. This is based on country. CN is China, and I think IN is India and US. And it will show you the hours of the day where your source user is coming from. So there are also some other metrics like a bar chart or whatever chart. You can also create your own visualization based on your needs. And moving on, dashboards. It's just a personalized dashboard. You can create your own and add in your own interested metrics or data that you want to monitor in your dashboard. This is alerting. Basically, this is a notification stuff. And let's say you set a threshold. If my 404 error is becoming too many, like 500 404 errors within 1 minute, I want to trigger an alarm to my email, to my team. You can do that from here. Index management. This is another big topic we don't have time to talk about, but I'll just show you what the UI looks like. You can create a policy to outdate some of the I would say legacy data, because the weblog you may only care about the most recent 1 month data, but not last year's data. So you can outdate that by creating a policy. And developer console. So here it's very similar to what you will be having, what you will be using in your code to access the Elasticsearch data, and it's going to follow the syntax like those. You can have more complex syntax. I don't think I actually prepared 2 pages of different queries I want to show you, but I guess we don't have time to map the specific field or specific values that you want to see. Yeah, so that's pretty much about it. And let me see if I can show you one Postman example. Just real quick. This is the last part. Some people, if you're more familiar, more comfortable with using a SOAP to make your API call testing or anything, feel free to use it. It's basically the same thing. And yeah, so here you see it does not have the Kibana plugin anymore. It's just following the standard, I would say, query syntax to check for your targeted Elasticsearch domain. It actually gives you a lot of information from here, including the shard number, the storage usage, and everything. Depends on what kind of commands you put over there, what kind of domain you put there. You can just query your domain differently. I provided some useful links you can refer to later. The PowerPoint is definitely shareable, and I think our team will put it somewhere so everybody can download. Yeah, that's all I have for today. Sorry for the time taking for this. Yeah, I practiced multiple times and it's never taking this long. I think it's because of the awesome questions that you guys asked in the process. It's kind of prolongs the presentation. But yeah, I can.
Yeah, thank you, Zidao. I see more questions coming in. So we can leave the questions to the end of the meeting. So before that, we have some other things to share. So please hold if you have questions and just wait online. This is a great lecture. Myself learned a lot from it. So I actually recently spent a lot of time on AWS cloud, and so I was able to obtain a couple of certificate on AWS cloud computing. So I know that each of the small service can take a few hours or even days to explain. So I was surprised that Zidao was able to manage this whole a lot of things in 1.5 hour around. So that's very cool. I think we all kind of appreciate this presentation. Thank you, Zidao. So then, you know that CADSEA is trying to serve this community, better and better. So we wanted to, develop more programs and more services that tailor to our needs, so that it can help us more. Our director of a membership, Jidong, would like to share some news with all of us. So with that, I want to turn over to Jidong.
Okay, yeah, thanks, Ken. Ken, can you hear me?
Yes, yes.
Okay, wonderful. Sure. Yeah, thanks everyone. I think also thanks this great topic on AWS. I want to use the following for 5 minutes to talk about the membership program run by CADSEA. So first of all, my name is Jidong. As Ken introduced, I work with Ken and other our CADSEA volunteers with the hope to group our program, to group our community. The membership idea actually was developed since the end of last year. We also discussed that during the last meeting. So today is still preliminary, but I want to give some high level information. Also, I want to leave some the way, for example, I will give the details such as email. So if people are interested or if people have the comments, suggestion, please let us know. I think 2020 will be the year we kind of establish, test, and run this program. I will talk about 4 topics. Number 1, what is that? Number 2, what's the detail? We may not have too much detail, but I still want to give as much as I know. Number 3, that is the volunteer run the program. I want to talk about what's that mean. Number 4 is how to reach to us. Okay, let me start. What is the membership program? Several people may attend our last year 5 event and also 2 event up to today. Going forward, in order to make this people are more involved into this topic, they want to kind of get more kind of customized or more deeply involved with that. So going forward, we are thinking about we will single out a program called membership. But that means if you are non-member, you are still okay, are still welcome to attend this traditional, this kind of open forum or seminar and other special event, but to become the member, you can benefit following things. Number one, after you sign up for the member, for this regular event, such as what today's talk about AWS, such as what the last year talk about the deep learning visual NLP image capturization. These are all kind of benefit, but it becomes a member after paying one-time membership fee. You can get the free admission to all of that. In addition to that, last year I think many people attend such as the barbecue event to let the people have more close connection. We are also design some the career training or mock interview or some similar program to let people also sharp off their soft skill. It's possible we will run the workshop and also last but not least is the annual conference. I still remember last year our annual conference we invite several keynote speakers, so they deliver a lot of good insights about their career development in or not in this the data science area. So I think this can benefit the member for a long time. We are still developing the website, the CADSEA website. After having that, all the past events, such as today's introduction, video, audio, or any reference information, such as any follow-up kind of YouTube link, we can put there. So member definitely have access to that website. We're also thinking about build up the kind of PBS or some email list system, so the member can stay closer with each other. We are also thinking about develop the newsletter, which talk about the industry trend, talk about if any career opportunity, we would like the member have the priority to receive the such information. So that's the general concept. For a lot of details, such as how much fee we would to collect, how that exactly run, we are still in the design stage. But I'm pretty sure we understand a lot of students attend us, so we will give the benefit or discount to student members. Let me quickly run. My third topic is about the volunteer. Like all the other work program, our membership program is also run by volunteer. So right now we have Lei, we have Nanyun, we have Hong. They are the volunteer for this program for several months. We kind of closely talk about, and we are looking for more volunteer to join to grow this membership program and also grow the whole CADSEA other program as well. So I want to stop here. Lei, are you online with me?
Yes.
Oh, Lei, yeah. Could you please talk briefly what's your thinking and how you encourage other people to join, please?
Yeah, sure. I have some understanding for the for this program. So if my understanding is not correct, please correct me, Richard or Jidong. So now I'm working with Jidong in building the membership program. So we have a lot of idea and plans right now. Like we can have some project, maybe from the Kaggle as a data science or machine learning project, or like project the cloud development project. We have many plans, but most of them under construction. So recently, the important things is we are exploring the resources and expert on hand currently in the community. So if any person have expertise in data science, machine learning, deep learning, finance, or anything, etc. Anything you think will benefit the community, please reach out to us. Since we rather than as a training school or headhunting company, I think our goal is to become a community. We want to build networks between us in the community. So we want to learn everything and build everything from scratch, uh, uh, which is good because we can learn together for new things, technology or domain knowledge. But I think it's better to not build everything from unknowns. So if we know some person already have some experience before, they can lead the team, and the members can learn the expertise from that lead, and the lead also can let the team members help him to implement his idea. So he also can benefit from the team. So that's our plan is uh, if you have any expertise in any field you think will make the community better, just reach out to us. So just like Zian, you give a pretty good presentation, a talk today, but I know due to the time issue, you cannot go deeper and show the details. But you can, if you are interested in that's good project, so you can lead some people and work that in details. I think that's pretty good. So that's our current plan. If you have any interested or have any idea, you can reach out to us. We can discuss details, what we can do and what we want to do in the future. Thank you so much.
Yeah, thanks, Lei. Yeah, I just want to closing this. We currently set up email address, which is membership.cadsea@gmail.com. This will use as the temporarily during this temporary period. I will also send the email address after today's meeting. We would like, we sincerely would like to hear your suggestion, your comments, how you would like, how you hope the membership program will be designed, will be run. I think the ultimate goal is we want to make sure that we will run efficiently, user-friendly, or more specifically, membership friendly. So that's all. So back to Ken. Thanks.
Thank you, Jidong and Lei, for the great introductions. I think we are all interested on this membership and are very looking forward to see it coming out soon. And I want to add to that is that so when you are here to attend this meeting, you are giving great support to our community already, and also I want to let you know that there are a lot of volunteers are currently contributing to CADSEA, and also we are actually, this meeting is free for public, but actually we are actually seeing regular bills coming in for all different kind of things. For example, we are a nonprofit organization. We have to file tax, and we have to pay for Zoom meeting, all that stuff, and emails. And so, so right now, a lot of volunteers are kind of contributing their time and donate to this program. So I think the membership program will definitely help us to keep this, CADSEA and this program going on for a long time. So without your support, we cannot be succeed. So then I think there are a lot of questions coming in for Zidao. I still leave a few minutes for you to to answer these questions. Zidao.
Yeah, sure. Thank you, Ken. Yeah, I'm open to any questions. I think there are a couple of questions already answered from the chat window, but you can speak up if you have additional questions.
So if no more question come in, we will stop here. We want to I really appreciate the presentation from Zizhao, and this is very great. So we want to, of course, we cannot give you, claps, round of applause, but we are really thank you for this lecture. And I think each of these topic can be, really few hours or a day of presentation. So we hope that in the future we have the opportunity to bring you back to the forum to give us a lot of more great lectures on AWS or different services. Yeah. All right then. There a new question coming?
What will be the next event?
Yeah, that's
so we can yeah, you can finish the last question. We make this the last question.
that's a very personal question. It's asking me about my daily life as a support engineer. I cannot really talk about that, due to the reason I mentioned at the beginning of the lecture. But just a private message. You can connect with me on WeChat, and if you want to know more about our services, or if you're interested to join our team, we're always hiring. Sorry, I don't know if I'm supposed to make advertisement here, but I'm more than happy to do internal referral to any Amazon positions, if anybody is interested.
Cool. Thank you. So before the end, I wanted to announce that we are going to have a forum scheduled right now for first week of June. I think June 7th. So we're inviting our expert to share a lot of interesting topics regarding how to use R to save you 1,000 of time, 1,000 hours of your work time. So right now we are still, finalize the agenda. So we will send out the flyer to you. If you register, you're going to receive the flyer in your email, or we will also, share the information in our, WeChat groups. So keep tuned. Thank you all for attending this meeting, and of course, thank you, Zidrao, for the sharing. And looking forward to seeing you all in the next event. Thank you.
Thank you.
Bye.
Thank you. Bye.